Hello everyone, welcome to Python Application Programming lecture series. In this lecture video, we are going to discuss about catching exceptions using try and except and short circuit evaluation of logical expressions. Try and excepts are the reserved word or keywords in Python. The try block lets you test a block of the code for error. The accept block lets you handle the error. Finally, the block lets you execute the code regardless of the result of the try and accept blocks. So let's consider a is equal to int of input enter a. B is equal to int of input enter B. This is the first statement and this is the second input. This is the first input and this is the second input. Python interpreter is asking the user input 1, user input A and user input B. This user input 1 is stored in variable and variable name is A. User input 2 is stored in B. C is equal to A divided by B. So division value we are going to store in C. So here we declare one print statement, print of C. The C is the divide values. So C is equal to A divided by B. When you run the code, one of the possible situation would be, so let's consider one sample. So here we enter A is equal to 12 and B is 2. So here A is 12 divided by 0. The Python interpreter will give the trace back, the most recent call last C is equal to A divided by B. So Python interpreter will give the runtime error, the zero division error. It will give the zero division error, the division by 0. So division by 0 is not possible. For the end user, such type of system generated error message is difficult to handle. So the code which is prone to run error must be executed conditionally with try block. The try block contains the statements involving suspicious code and the accept block is contain the possible remedy or instruction to user information what went wrong and what could be the way to get out of it. If sometime goes wrong with the statement inside try block, the accept block will be executed. Otherwise, the accept block will be skipped. Let me rewrite the same example. Here A is equal to int of input enter A and B is equal to int of input of enter B. So these two lines asking the user input. The first input is A and second input is B. Here we declare the reserved word. The declared reserved word is try colon. So this is the syntax for try. Now we declare one more variable. The variable is C. C is equal to A by B. So resulting value is stored in C. So now we print the C value. And again here we declare accept. Here we declare accept colon. So now again we print the division by 0 is not possible. So previously we are not declare try and except. So directly we we enter the a and b value, then we divide the a and b, then we print the c value. So previously we are not declare try and except. So let's consider one sample output. So enter 12. Enter A is 12 and enter B is 0. B is 0. So in previous case, if we enter 12 and 0, so Python interpreter will gives the error, gives the runtime error. Now, so Python interpreter will gives the division by 0 is not possible. So here, so already we declare the except condition. So except condition is divide by 0. So print division by 0 is not possible. So its interpreter will display the division by 0 is not possible. So let's consider one more example. Enter A is equal to 12 and enter B is equal to 2. So here A is 12 and B is equal to 2. So here A is 12 and B is equal to 2. If you print C value, the resulting value is 6. And previous case, A is 12 and B is 0. The Python interpreter it's skip this and execute the last statement. If both are integer values, 12 and A is integer 12 and B is integer 2, the Python interpreter is execute this and skip the except statements. Note that handling a exception using try is called as a catching an exception. In general, catching an exception gives the programmer to fix the probable problem or to try again or at least to end the program gracefully.
Let we execute this in interpreter. So A is equal to type conversion int of input of enter A and B is equal to int of input enter B. So A is the one user input and B is the another user input. So C is equal to A divided by B. Print C. So this is one simple code. Just you run this code. If you run this code, so Python interpreter is asking the user input A. Here you type A is equal to 12. Again interpreter is asking the one more input, just you type the B is 0. Now you enter. So Python interpreter will gives the traceback error. The most recent call is lost. The recent call is C is equal to A divided by B. So 0 division error. So it will gives 0 division error, division by 0. So our program is proper, but Python interpreter will gives the runtime error. So this type of error is handling is very difficult. So just you modify this code, enter try. So try, type try, and here you accept, declare accept here, accept. So print 0 division is not possible, so just you run this. Just you run this. So just you run this code. So Python interpreter is asking the A. So A is the first user input. Here we type 12, enter, and again interpreter is asking second user input. So here you type 0. Just you type 0, enter. So Python interpreter will gives that division by 0 is not possible. So here A is 12 and B is 0. So here we declare try and accept. So if both values are integer, so this block is going to execute. So otherwise, so this statement is going to execute and skip this statements. So here values are 12 and 0. So this term try C is equal to A by B and print C is ignored and execute this one. So it will displace division by 0 is not possible. So again you run this code. Here you enter input A is 12 and B is 2. The result value is 6. The resulting value is 6. So here A is 12 and B is 2. So try statement is going to execute and you skip the accept statement. So here C is equal to 12 divided by 2. The printed value is 6. Using try and accept keywords, so we can easily avoid the runtime errors in Python.
Now we will look into short circuit evaluation of logical expressions. When a logical expression involving operands and or and not is being evaluated, it will be processed from left to right. So let's consider one statement. The statement is x is equal to 10. 10 we assign to x and y is equal to 20 if, here we declare one condition. So if x less than 10, x less than 10 and is the logical expression, x plus y is greater than 25 colon. So this is the condition. So this is the logical expression, x less than 10 and x plus y is greater than 25. It's doing something. So here the expression x less than 10 and x plus y greater than 25 is involves the logical operators and. Now x less than 10 is evaluated first, which result to be false, as there is an operator the irrespective of the result of x plus y greater than 25, the whole expression will be false. In such situation, Python ignores the remaining part of the expression. This is known as short-circuiting evaluation. When the first part of the logical expression result is true, so this is true, then the second part has to be evaluated to know the overall result. So if this is true, the interpreter is going to evaluate the second statement. If this is false, so Python interpreter is not going to evaluate the second value. It totally depends on x and y values. So evaluated to known as overall result. The short circuiting not only saves the computational time, but it also leads to a technique known as a Gordian pattern. So in this particular case, x we assign to 10. So here in first condition x is less than 10, but here x is 10. So this condition is false. So Python interpreter is not going to execute this. So for example, you consider x is equal to 5 and y is equal to 2. Y is equal to 2. So here x assigned value is 5, so it's less than 10. This condition is true. The Python interpreter is going to execute the second statement. The second statement is x plus y greater than 25. Here x is equal to 5 and y is equal to 2. 5 plus 2 is 7. 7 is less than 25. So this condition is false. It's not going to execute this. Let's consider sequence of statement. So here the statement is x is equal to 5 and y is equal to 0. So 5 we assign to x and 0 we assign to y. X and y are the variable. We stored 5 into x and 0 into y. So here we declare one condition: x greater than or equal to 10 and is the logical operators. X divided by y is greater than 2. So this is the statement. So here in this statement, when we execute the statement x greater than 10, so this is the x greater than 10 and x by y greater than 2. The first half of the logical expression itself was false. So this statement was false. So x assigned value is 5. So 5 is not greater than or equal to 10. The first condition is false. If first condition is false, hence by applying short circuit rule, the remaining part was not executed at all. So this is the remaining part. So when first condition is false, the remaining part is not going to execute it. So let's consider one more statement. Here x greater than or equal to 2 and x divided by y is greater than 2. So here x is equal to 5 and y is equal to 0. So this is the first condition and this is the second condition. Here wherever in the statement x greater than or equal to 2 and x divided by y greater than 2, the first half is true. So this is the first half. First half is true because x is equal to 5. So 5 is greater than 2. The first condition is true. So and the second half is resulting in a runtime error. Because y value is 0. So x is 5. 5 we divide by 0. Second half is resulted in runtime error. Thus, in the expression x greater than are equal to 2 and x divided by y greater than 2, the short circuit rule is acted as a guardian by preventing an error. One can construct the logical expression to strategically place a guard evaluation just before the evaluation that might cause an error as follows. So here let's consider one statement: x is equal to 5 and y is equal to 0. Here the x greater than or equal to 2, this is the first condition, and y is not equal to 0 and x divided by y is greater than 2. So here x greater than or equal to 2, the result is in true because x is equal to 5. So 5 is greater than 2, but y is not equal to 0. So this is the second condition, y is not equal to 0. So here because y is 0, so y is equal to 0, the evaluated to be false, evaluated to be false, hence the expression x divided by y greater than 2, so this is the third condition, x divided by y greater than 2 is never reached and possible error is being prevented from happening. Now we will see debugging. One can observe from the previous few examples that when a runtime error occurs, it displays the term traceback followed by a few indications about errors. The traceback is the stop trace from the point of error occurrence down to the call sequence till the point of call. This is helpful when we start using the functions and when there is a sequence of multiple functions calls from one to other. Then the traceback will help the programmer to identify the exact position where the error occurred. Most useful part of the error message in tracebacks are what kind of error it is, where it occurred, compared to the runtime error, syntax error are easy to find the most of the times, but white space error in the syntax are quite tricky because spaces and tabs are invisible. For example, x is equal to 10 and y is equal to 15. So 10 we assign to x and 15 we assign to y. So here the interpreter will give the syntax error. So unexpected indent is the error. So the error here is because of the additional space is given before y. Yes, just you look at this. The y is equal to 15. So between y and equal there is a space. As a Python has a different meaning space block of code for indentation. One cannot give extra space as shown above. So in general, error messages indicate where the problem has occurred, but the actual error may be before that point or even in the previous line of code. These are some references. Thank you.